Hey guys, Mr. O'Sullivan here. Hey, we're getting ready to go through AB number 2, the homework problem. And before we start, I'd like to just again thank Jeff Osborne, AP Calc teacher at Central Columbia High School in Bloomsburg, Pennsylvania, for creating this awesome problem. All right, so here it is. And you might recognize it. Looks like it's going to be a piecewise defined graph, and have some questions kind of relating to that. So the graph of f, consisting of 3 line segments in a quarter circle of radius 2, is shown below, and it's given that g at x is equal to the definite integral from 1 to x f at t dt. Okay, well, again, as soon as I see this definition of g at x, I almost can't help myself, and I just know that fundamental theorem of calculus part 2 is going to tell me that the derivative of this, g prime at x, is equal to, I'm just going to basically take that variable and plug it into my integrand. And so g prime at x is equal to f of x. Okay. So what I want to do is on my graph here, this is the graph of f, and I'm just going to say f is equal to g prime. And so really anywhere I'm dealing with f, I can interchange it with g prime and vice versa. So that's important just to kind of establish that relationship. All right. Part A asks for find the values of g at -4, g at 1, g at 3, and g at 4. Okay. Well, g at -4, I'm just going to copy down g at -4, and I'm just dropping it into my equation for g at x. So g at -4 is going to be the definite integral from 1 to -4 f at t dt. So to evaluate this, I'm going to go to the graph of f, which is right above here, and I want to evaluate it. I'm looking for the area between the function f and the x-axis, and I want to integrate from 1 to -4. So again, I'm going to go from 1 to -4. So I'm going to be integrating from right to left. So what might be helpful, and I'm going to have to probably refer to this a lot, is I'm going to break up the these areas between my function, the x-axis, into kind of my known shapes. So this first one is going to be this triangle. And what I'm just going to do is I'm just going to write the area of that triangle. Well, that looks like it's 2 units for the base, 4 units high. So 1/2 the base times the height is going to be 4 square units. And that would be, again, the area of that. Okay, now I move next door to the quarter circle. And I can see that has a radius of 2 units. And so it's a quarter circle. So that's going to be pi times my radius squared, which would be 2 squared. And then, but again, I have to remember it's a quarter circle, so I divide that by 4. So that's just going to simplify down to be just pi. So that region right there has an area of pi square units. And move over, I've got a smaller triangle here. That looks like that is 1 unit by 2 units. 1/2 the base times the height is going to be 1 square unit. Over here, I have a triangle. And that looks like it's 2 units. And the height is also 2 units. So 1/2, 2 times 2 is going to be, so that's going to be 2 square units for that triangle. And then last but not least, this triangle. Yeah, it looks like that base is 1 unit. Looks like the height, 2 units. So 1/2 the base times the height That makes sense. That's kind of the reflection of my red triangle right there. Okay, so I've got, again, those are the areas of those regions between my function and the x-axis. So for this first one, what I have to recognize is that my lower bound, 1, is greater than my upper bound of -4. So again, I can think of this, I'm integrating from right to left. And so anything above, where my function is above the x-axis, since I'm integrating right to left, I have to reckon that as a negative value. And then conversely, any area that is below, where the function is below the x-axis, I'm going to reckon that as a positive value. So starting at 1, first off, I have this region here, that area 1. Again, I'm going to treat that as -1. Plus, now I have this region that is pi square units, but again, I'm going to treat that as -pi. And then going all the way to -4, so I include this large triangle. That's going to be -4. So there's my numeric value for g at -4. Okay, g at 1, going to like that one. G at 1, same thing. Lower bound of 1, upper bound of 1. Well, if my lower and my upper bound are the same, means the value of my definite integral is 0. Okay, g at 3. So that's going to be from 1 to 3. Okay, now my lower bound is less than my upper bound. So I'm going to be integrating from left to right for this one. So I'm going from 1 to 3. So I want to go from 1 to 3. So I'm interested in that value right there. Again, integrating from left to right. My function is below the x-axis, so I'm going to reckon that as -2. And then last but not least, g at 4. Drop that into my equation for my function, lower bound of 1, upper bound of 4, f of t, dt. I'm going from 1 to 4. So I'm going to reckon that 2 again as -2 plus 1. I'm going to include that 1 in that last, that pink triangle. So that's going to be the value of g at 4. Okay, next part, on the interval from -4 to 4. So again, I want to be cognizant of that interval, -4 to 4. At what values of x does g at x have relative maxima and relative minima? Give reasons for your answers. Well, g at x is going to have a relative max and relative min when g prime, just going to write that, g of x has relative max when g prime changes from, well, relative max, I always kind of remind myself, relative max looks like that. That means the derivative must be going from some positive value to some negative value. So g at x has a relative max when g prime changes from positive to negative. And again, I have to remember g prime is the same as f of x. So I want to look at f of x. Some of this up a little bit. I'm going to leave my areas in there in case I need those a little bit later, but I am going to take out so I can see the function a little bit better. Okay. So I'm looking where g prime, which is also f, changes from positive to negative. Now here, that's tricky. It's positive, but then it goes back to positive. So that's not what I'm interested in. But right here, from positive to negative, and that would be at x equals 1. And then g at x has a relative min when g prime at x changes from negative to positive. And that's going to occur, now I'm looking where g at x, or f of x, changes from negative to positive right here. It goes from negative to positive, and that's at x equals 3. Okay. All right. Moving on to part C. On the interval again, from -4 to 4, what are the absolute max and absolute minimum values of g at x? Well, as soon as I see the word absolute max and absolute min, I'm going to set up a table. So I'm going to set up x values in the left column. I'm looking for maximum and minimum, absolute max and absolute minimum values of g at x. So that's my right column. I'm going to start by including the endpoints. So -4 and 4. And then I have to look at any critical numbers of g at x. And that's going to be, these are my endpoints, EP. These are my critical numbers. And this is where g prime of x is going to equal 0. And what I can look at, I'm going to exclude that one. That would be a critical number at x equals -2. But since I'm asked to find absolute max and absolute min, there's no way that that could be a relative max or relative min, and therefore possibly be an absolute max or an absolute min, because the derivative doesn't change sign. So I'm going to save a little time, exclude that, but I do need to check right here where my derivative changes from positive to negative and from negative to positive. So I do want to also check an x value of 1, 3, and I've already done all the heavy lifting, because if I go back to part A, I can see every one of those values I have to check I found in part A. So g at -4 is equal to, I guess I could probably simplify this a little bit, because that's going to be -5 minus pi. So that's my value g at -4. -5 minus pi. Again, this is all coming from part A. G at 4. G at 4 looks like it's going to be -1. G at 1 is 0. And G at 3 is -2. Okay. Now, I want the absolute maximum. So again, I'm looking for not the x value where the absolute max occurs, but the absolute max itself. So I'm looking in my g at x column. I'm looking for the largest value, and there it is right there. 0 is my absolute max. And now I want the absolute minimum value. Well, that looks like that's going to be -5 minus pi. That's my absolute minimum value right there. Okay. Okay, part D, once again, on the interval from -4 to 4, at what values of x does g at x have points of inflection? Give a reason for your answer. Well, I know I could either talk about where g has a point of inflection either in terms of g prime, its first derivative, or its second derivative. Since I've already got this graph of f, which is equal to g prime, I'm just going to stop at the points of inflection of g just in terms of what g prime is doing. So I know that g has a point of inflection when g prime goes from increasing to decreasing, or vice versa, decreasing to increasing. Okay, and I'm just going to say this occurs at x equals, so now again, I'm just looking at my graph. Well, right here, my graph is decreasing, changes to increasing. So that's 1, x equals -2. Now my graph is increasing. Just do this. I'll show this is where my graph is decreasing, just show that in red. And then in blue, just show where my graph is increasing. So it looks like I've got one there at x equals -2, got another one at x equals 0. And I have a third at x equals +2, changes from decreasing to increasing. Okay. And last part, calculate the value of the definite integral from 1 to 4 of the absolute value of f of t dt. All right. Well, the easiest way to look at this could be a couple ways you could look at it maybe. I'm just going to bring this graph. Okay, so I've got my graph. And I'm interested in the definite integral from 1 to 4. 1 to 4. So I'm looking really from 1 to 4. And then it's the absolute value of f of t. So what I can do is I can kind of take this segment that is below the x-axis where f of t is negative on that interval. And what I'm going to do is I'm going to flip it. So now it's above. Okay, so that, now I'm looking at, this is the absolute value of f of t from 1 to 4. Okay, well now I already established the area of this triangle. That was 2 units by an altitude of 2 units. So 1/2, 2 times 2, that's going to be 2. And I'm going to treat that as +2. Okay, because again, I flipped that because it was the absolute value of f of t. And then I also need to include this portion right here. That was 1 by 2, 1/2, 1 by 2. That's going to have 1 unit. So that's going to be 1. So the value of that definite integral from 1 to 4, absolute value of f of t dt is equal to 3. Okay. All right, guys, I hope that helps. Thanks.